I'll just tell you a little about why I choose Sierra Circuits. At Sierra Circuits, we have design, fabrication, and assembly all under one roof. And the seamless integration between the layout engineers and fabrication experts enables fast iterations, fewer errors, and better performance. Our dedicated design engineers will help you with real-time DFM and DFA feedback. This prevents costly rework and delays. Designing a high-frequency circuit board is not a joke, and it requires precise technical knowledge and expertise in signal integrity, trace routing, and material selection. Sierra Circuit's design team is capable of addressing exactly that high-speed PCB design challenges, like achieving consistent line impedance, reducing signal reflections, and managing crosstalk between edges and traces. This will be the agenda for today, basically outlining how Sierra Circuit handles high-speed design jobs. Let's start with how to choose low-loss materials. While designing high-speed jobs, our design engineers select materials with a DK less than 4 and DF less than 0.005. To reduce the skin effect losses at high frequency, we usually use low-profile copper foils, such as hyper low-profile HVLP, reverse-treated foil, RTF, and ultra-low profile. Being tied up with our in-house fab team, we understand the importance of selecting a laminate with a CTE that aligns with that of copper. We at Sierra use our PCB material selector tool to make the right decision when choosing high-speed materials. Here you'll see how our tool helps. So I'll just show a quick demo on a material selector tool. So this is a material selector tool that allows you to search and filter out the rigid and flex materials from the database that best suits your design needs. You can scroll all the way down here and click on this Go Submit button, and all the materials available in the all the rigid materials available in the data will be displayed there. Then we have all of these various categories that will help you with the material selection. The first being the material type. You can choose a flex or a rigid board. You can click on yes for a halogen-free material and on all if you want a halogen-based material as well. You can also click on this very high thermal conductivity if that's your requirement. Under electrical properties, in the speed loss section, we have a drop down here that categorizes all the materials into these categories. Let's go with high speed, low loss for now. And then we have three input parameters here. That is the maximum signal frequency content, fastest signal rise, and the highest data transfer rate. You can click on any one, you can enter any one of these parameters and the others will be automatically calculated. For example, let's go with 10 gigahertz here. When I click outside, the other two are already calculated and displayed. You can use these sliders over here to choose the range of your dielectric constant, similarly for dissipation factor and dielectric electrical strength. We have a drop down here for the CTI class and voltage. And under thermal properties, we have the glass transition temperature, decomposition temperature, CTE in the XY axis and the Z axis, and of course the thermal conductivity. Under chemical properties, we have moisture absorption and an option to choose CAF resistant materials as well. In mechanical properties, we have the tensile modulus, tensile strength, and the flexural strength. Lastly, we have a drop down for the family name, which you can choose one of these, and those materials will be provided. Similarly, we have a drop down for material manufacturer, IPC number, and the slash number. Now click on Go Submit, and all the materials that belong to the criteria that you have chosen will be displayed over here. You can click on this view button to view the data sheet of that particular material. You can also change the unit system here from imperial to metric if you wish to do so. You can click these tick boxes over here to all your desired materials and click on this compare button, and it will show side-by-side comparison of all the properties of these materials. We have also provided a column over here that basically states if the material is HDI preferred or not. Let's get back to the presentation now. We start with handling high frequency traces and reference plane. One of the most important thing in ensuring uniform impedance. When routing high-speed circuits, our designers thoroughly check for impedance discontinuities. We implement daisy chain routing and maintain a spacing of at least 3 Ws between traces, where W is of course the trace width. Additionally, our designers incorporate series and parallel terminating resistors at the driver and the load end respectively. I'll just give another quick demo on our impedance calculation.